Okay, in lesson 610, we're going to look at how to analyze solutions to quadratic equations, and we're going to be doing that by using something called the discriminant. But we'll get to that here in a minute. But first of all, let's review a couple of things. One is I have written up here, I have our quadratic formula, which we'll talk about that again in a minute and how we're going to use that today. But if you think about it, when we use the quadratic formula, what we're doing is we're looking for the number of solutions that work in that equation. In our solutions that we're finding are, in reality, are our x-intercepts. So if I were to graph a parabola and it looked like this, well, if I use my quadratic formula, I would end up having two solutions, and my solutions would be my x-intercepts. Or sometimes we can have our quadratic formula where we get only one solution. And if we were to graph that, in that case, our graph would look something like this. Now remember, most recently we've talked about imaginary numbers, and sometimes when you use a quadratic formula, you end up getting a square root of a negative number, which isn't technically possible, so that's where the imaginary number comes in. Well, the reason for that is if we were to graph a situation in which we end up with a negative number under the radical, if you were to graph that, it doesn't touch the x-axis. There are no x-intercepts. So, again, looking at these three examples, and this first example here was where we have two solutions for our quadratic formula. This is one where we have one real solution in our quadratic formula, and this is where we would say we have no real solutions. So we could even fill it in like this. Now, if we just wanted to know how many solutions an equation had, rather than having to use the entire quadratic formula to figure out how many solutions there are, there's a part of that quadratic formula that's going to tell us how many solutions it is. And that part is just this piece that's underneath the square root. Now notice I did not highlight the square root part. I only highlighted the part that was underneath it. This part here is what we call the discriminant. Oops. The discriminant. So technically the discriminant is just the b squared minus 4ac. Now here's what that part tells you. That part tells you, again, how many solutions it has. If we do b squared minus 4ac, and if we get a number that's positive, that's greater than 0, that means that we have two real solutions, because we're going to have a plus or minus some number. So we're going to end up with two solutions. A plus or minus are both going to come in. If we end up getting b squared minus 4ac, and I get exactly 0 as my answer under the radical, well, that means the plus and minus are not going to come in. I'm just going to have the opposite of b divided by 2a, which means I'm only going to have one real solution. If I end up with b squared minus 4ac being a negative number, meaning it's less than 0, that's where we're going to have no real solutions. Another way to look at that is we would say it's also two non-real solutions. But in essence, that's what we're going to be looking at today. So this is kind of the summary of what you need to know for today's lesson. So the b squared minus 4ac, notice how we don't have the square root there. Never, ever, ever take the square root of that. It's just the b squared minus 4ac. That's all we use to figure out whether or how many solutions a problem has. Now, it does not tell you anything about the answer. If we get 14 as our answer, that does not mean that the x-intercept is at 14 and negative 14. It's just that if I get a positive 14 as my answer, that tells me that there's two real solutions. And from there, I would take, if I wanted to find the actual solutions, I'd have to put 14 back underneath the radical. So I'd have to take the square root of it and then carry out with the rest of the quadratic formula. So let's actually look at some problems so you can see more what we're talking about here. So let's go to our notes here. Something else that's important to take note of is that the solutions, not only are the solutions that we find for the quadratic formula, not only are they the x and y intercepts, But another term for those are the zeros, or the roots of the equation. So if they ever ask for find the roots of this formula, or find the roots of this equation, or the zeros for this equation, they're looking for the intercepts. So we would use the quadratic formula. So everything that's summarized here in this box is stuff that we just talked about on that previous sheet. So here's an example. It says determine the nature of the roots of each equation. So the way this is phrased is kind of confusing. You might know, what are they talking about? Well, they're asking us to find the roots, which again are the same as the x and y intercepts. So what we want us to use is the discriminant. We're going to use the discriminant here for each of these. So b squared in this first case is negative 4 minus 4 times a is also going to be 4, times c, which is a positive 1. Again, there's no square root here. I'm just taking the b squared minus 4ac and just going to solve this. And you should be able to do this without a calculator. Or if you do it with the calculator, please do it step by step, because I want you to see and catch any mistakes. So I don't want you to just plug this all in your calculator all at once. If you do this with the calculator, I want you to first take negative 4 squared, because you should get a positive 16. Anytime you use a negative number and square it, you should get a positive answer. If you did that on your calculator and you got negative 16, it's because you did not put the negative 4 inside of parentheses before you squared it. But again, you should be able to do that without a calculator. Then it's going to be a negative 4 times 4 is a negative 16 times 1 is a negative 16 still, so it's going to be minus 16, which equals 0. So it tells me that if I get 0 as my answer, there's one real solution. Again, if you get 0 as your answer, that does not mean there's no real solutions. That means that there's going to be one real solution. Okay, so let's look at the next one now. The next one, we would take b squared, again, minus 4ac. b in this case is 6. So it's going to be 6 squared minus 4 times a, which is 25, times c, which is 4 again. When we do that, 6 squared is 36. Negative 4 times 25 is negative 100, times 4 is negative 400. Now, in reality, we really don't care what the exact answer is, because the exact answer doesn't really do anything for us. We're just trying to figure out whether the answer is positive, negative, or 0. We can see here that it's obviously not going to be 0. The fact that I'm taking 36 minus 400 tells me my answer is going to be negative. So that tells me that if my answer is negative, well, underneath the radical, that would include, or that would imply that I would need to use imaginary numbers. So there's going to be no real solutions. If you'd actually solve this out, 36 minus 400 would be negative 364. But again, I want to emphasize the fact that in reality, we're looking to see whether it's positive, negative, or 0. Let's look at the last one. Again, so it's going to be b squared. So b in this case is a positive 5. So it's going to be 5 squared minus 4 times a is 3, times c, which is negative 14. 5 squared is 25. This one you might need to use a calculator for. Negative 4 times 3 is negative 12. This is a part that should use a calculator. Negative 12 times negative 14 is a positive 168. So this time we have 25 plus 168, which is going to be, again, even if you didn't add those together, you'd know that it's going to be a positive answer, meaning that I'm going to have 2 real solutions. And again, if you were to add these together, technically you'd get 193 as your answer. Okay. Why don't you guys take a minute now and work on these last 3 problems. Try these on your own to make sure you understand how to do these. And so why don't you hit pause, hit play when you're ready to check your answer. Okay, so you can see now, you can check your answers. So the first one, you should have gotten no real solutions. B, you should have gotten 1 real solution. And C, you should have gotten 2 real solutions. If you did not get that, you can pause the video and check my work here to see where you made your mistake at. I want to get to a story problem here. Let's look at this example here. It says, 8-year-old Allie Oop, an aspiring basketball player, shoots 5 feet from the hoop. She's trying to get the ball above the rim, which is set to a height of 10 feet. She releases the ball from an initial height of 4 feet. The following equation models the path of the ball, where x is the horizontal distance in feet the ball has traveled, and h is the ball's height in feet above the ground. Now there's a slight Typo here. This should be an exponent. So our equation here that we're going to use is negative 0.4x squared plus 3x plus 4. We want to use the discriminant theorem to determine whether Allie's ball ever reaches the height of the rim. So in reality what we have is we have a situation where the height of the rim is 10 feet. So we would have this equation of 10 equals negative 0.4x squared plus 3x plus 4. Well, in order to use the discriminant, remember that's part of the quadratic formula. In order to use the quadratic formula, our equation needs to be set equal to 0. So what we're going to do here is we're going to look to see, or we want to solve this equation first to see what it's going to be equal to 0. So I do that by subtracting 10 from both sides. So this would be the equation we're going to solve, or that we're going to use a discriminant theorem for. And in reality, what's happening here, if you need a visual, is if we have our basketball hoop, and here's little alley-oop. Well, she's shooting. Well, we want to see not so much if she'd make it, but see if she's throwing the ball high enough to make it. And so the way that we figure that out is by using our quadratic formula. Right now, looking at this parabola, the height of the ball would be 10 feet. Well, if we were to shift that parabola up, is basically what we're doing is we want to see now, using the height of the rim as our x-axis, we want to see does it ever reach that height. So essentially that's kind of what we're doing. That's a way that you can think of it. So we're going to use a quadratic formula to see if it ever reaches a height of 10 feet. So it might reach, if we use a discriminant and we get exactly 0, that means that the highest the ball reaches is 10 feet. If we get 2 answers, that means the ball reaches 10 feet twice, so that means that she does have a chance of making it. Or if we get an answer, or just using our discriminant, if we get a negative number, that means that it doesn't reach 10 feet. So that means that there's no way that she could have possibly made it. So let's use our discriminant to see what the situation is here. So it'd be b squared, so b in this case is 3, minus 4 times a in this case is a negative 0.4, times c, which is a negative 6. When we simplify this, 3 squared minus 4 times negative 0.4 times negative 6, I'll just tell you, you get a final answer of negative 0.6. So meaning that there's no real solutions, so it doesn't touch the rim. So why don't you do the same thing now for this example. So pause the video and hit play when you're ready to check your answer. Okay, so let's see what you got here. It says the equation models the path of a ball. Again, in this case, we're trying to use the discriminant theorem, this time to see if the ball reaches a height of 4 feet. So what you should have done is you should have put 4 into this original equation. Set it equal to 0. It's always your first step. Make sure your equation is equal to 0 first. Then we use our discriminant, and this time we get a discriminant. Our answer is 0.8. Now the fact that it's a positive answer means that there are 2 real solutions. Well, in reality, as far as for this problem, what that means is that it means that it reaches the 4 feet, the height of 4 feet, at 2 different times. Once when it's going up, once when it's coming back down. Again, it doesn't tell us whether or not they made it. It just tells us that this individual threw the ball high enough where it could have made it into the basket. So hopefully you understand now how to use the discriminant, and good luck on that assignment.